Today in this video tutorial, we are going to learn about sets, which are the fundamental to our learning of mathematics. So let us first start out with the definition of sets. The sets are a well-defined collection of objects. For example, here n denotes the set of all natural numbers. Now let us look into the basic notations used in the set. If A belongs to the set A, then it is written as and we write it as A epsilon the set A, for denoting that A belongs to the set A. Here ns denotes the number of element in the set S. Now let us look into the various representations of the set. So the first form is the roster form, in which the elements of the set are represented as, for example, the set of natural numbers can be represented as n equals to the curly braces, then the element 1 comma element 2 comma element 3, and so on. The next representation is the set builder form. In this, a single property common to all the elements of the set is used to represent the set. For example, n equals to set of all natural numbers represents the set of all natural numbers which share the common property that they are integers greater than or equal to 1. Here are basic common set which occur frequently. The first one is the empty set. The set which does not contain any element is called an empty set and is denoted by phi. The number of elements in such a set is equal to 0. For example, the set of the numbers which are greater than 2 and less than 1 is null, because there is no such element which is greater than 2 and less than 1. The second set in this frequently occurring set are the finite set. In this, the number of elements is a finite natural number. For example, the set of the students which are present in your class is a finite number, and thus the set representing it is a finite set. The third set is that of the universal set, which contains all the elements in the given space. Now let us look into the concept of equal sets. If every set of A is an element of Now let us look into the concept of equal sets. If every element of set A is an element of set B, and every element of set B is an element of set A, then A is said to be equal to B and is written as A equal to B. The next concept is that of the subsets, which is an very essential part of our understanding of the later chapters. So let us mark it out with a star. So let us first look into the definition of subsets. These subsets The set A is called the subset of set B if every element of set A is an element of set B. In mathematical notation, it is written as A is a subset of B and A belongs to the set A implies A belongs to set B. For example, the empty set contains 0 elements, so it is by default the subset of every other set. Let us look into a more common example. Let set A denote all the students in your class and set B denote all the students in your school. Then set A is the subset of set B because the students who are in your class study in your school also. So the student who is part of your class is also the part of your school. The next concept is that of common set. There are certain sets which are commonly used to represent the functions which we'll study in the later chapters. So let us start by n, which is the set of all natural numbers. The second set is that of the set of integers, which is denoted by z. The third is that of all the rational numbers, and r is used to denote the set of all real numbers. So, as you know, the set of integers include all the natural numbers. Therefore, n is a subset of z, which is a set of all integers, which is itself a subset of rational numbers, which is a subset of real numbers. There is another set t, which is used to denote all the real numbers which are not rational numbers. That is, t represents all the irrational numbers. Here, t is a set of real numbers. So, here's a short exercise for you. Check whether W, the set of all the whole numbers, is a subset of R or not. Here, now I introduce to you the most fundamental and the frequently used concept in the set theory for explaining and understanding of the different concepts, the Venn diagram. Venn diagram is basically a circle in which the elements of the set A are written inside the circle and elements not belonging to the set A are written outside it. So here the set A consists of elements 1 and 3. So the set A is 1 comma 3 in the roster notation.